In Proposition 18, what we're going to show is that in a triangle, the greater side will be associated with the greater angle. So the text says, in any triangle, the greater side subtends the greater angle. So given that one side is greater than another, the opposing angle to that greater side will be larger than the other angle. And let's set this up. For let ABC be a triangle having the side AC greater than AB. So we'll draw this up. This will be our triangle ABC. Label the vertices like so, ABC. Notice that AC is going to be greater than AB. The claim is that I say that the angle ABC, which is opposite the greater side, he says that this is also greater than the angle BCA, which, as you notice, is opposite the smaller side. That's a claim, and we now proceed to prove it. For since AC is greater than AB, let AD be made equal to AB, using proposition number 3. So what we're going to do is, from AC, which is the greater side, we're going to cut off a segment equal to AB. So how do we do this? We place the center of our compass at A, letting the radius be AB. We draw out enough of an arc to note the intersection point, and we call this D. And he says, let BD be joined. So we'll just connect those two. And note that we have AB equal to AD by proposition 3. And you'll note that down here we have the smaller triangle BCD. And Euclid notes that since the angle ADB, which is this angle right here, that's an exterior angle of the triangle BCD, this lower one right here. And by proposition 16, it is therefore greater than the interior and opposite angle DCB. So he's saying that this exterior angle must be greater than this interior and opposite angle DCB. And that's true by proposition 16. So to keep track of our angles, we have the angle ADB, and we've noted that it's greater than DCB. Now also note that since we have AD being equal to AB, it follows from this that ADB is equal to ABD. Now, why is that true? Remember proposition number 5. If we have two equal sides here, in this triangle ABD, it follows that the angles opposite this isosceles triangle are equal. So ADB is going to be greater than ACB, but ADB is equal to ABD because of this isosceles triangle. Therefore, we have, at this point, ABD is greater than ACB. And this is just what he says. Since the side AB is equal to AD, AB is equal to AD, the angle ABD, that's this angle right here, is also greater than the angle ACB. However, notice that the angle ABC, with respect to ABD, ABD is a part of ABC. So therefore, ABC is still greater. And therefore, Euclid notes, therefore, the angle ABC is much greater than the angle ACB. Because notice that ABD is but a part of ABC. Therefore, it follows that this angle ABC, which was opposite the greater side in the original triangle, is bigger than the angle opposite the smaller side, AB, in the original triangle. And that's the proof.